So good morning students. In the last class we were discussing on unsymmetrical bending. Okay. Now next topic is shear center. Okay. So what do you mean by shear center? See, for symmetrical sections, here you have a symmetrical section. That means this one is symmetrical. Say this is a square, this is A and this is A, all sides are A. Okay, so if you apply a load on this cantilever at the end, and this load is applied through the centroidal axis. Okay, this is its centroidal axis or symmetrical axis. Then what happens is that this object will bend. Okay, this object will undergo pure bending. This is only for symmetrical section. So for symmetrical section only m by I is equal to sigma by y is equal to E by R. Okay, now if you consider the case of an unsymmetrical section, an angle section or unsymmetrical I section, and here if this be the centroidal axis, vertical centroidal axis, then what happens here is that if you apply load along this direction, this thing will bend as well as it will twist. Okay, so you can physically analyze this one. If you apply a load here, there is a chance that this object is bent as well as it has undergone twisting, bending as well as twisting. Okay, so in order to avoid this twisting and to get a pure bending, we are introducing a new term called shear center. Okay, so now what is its definition? When a beam has unsymmetrical cross section, that is very important, unsymmetrical cross section, and if applied load passes through the centroid of cross section of beam, when applied load is passing through the centroid of the beam, then there will be a twisting in addition to bending in the beam. Okay, in order to avoid twisting of the beam and to have pure bending, load has to be applied through some appropriate point. Okay, so in order to see, you are applying this load in order to prevent from this twisting which is caused by this load. You need to apply a load on some other point to remain the twisting effect in equilibrium, and this point is called shear center of flexure or flexural center or center of twist. Okay, I hope that you got what I am telling. See, if this in an unsymmetrical section you are applying a load on its centroid, then together with the bending effect, this will move downwards as well as it will twist along this side. So in order to avoid this twisting, you need to apply a load somewhere around this shear center varies according to the symmetrical section, but whatever it may be, you need to apply a load at a certain point to avoid this twisting, and that point is termed as shear center. Now see what are all its characteristics. We'll see. For a symmetrical section, if a load is applied on its centroid, the object undergoes pure bending as shown in first figure. Okay, here in the first figure it's shown that it is undergoing pure bending. But in case of unsymmetrical section, when load is applied on the centroidal axis, it experiences a twisting effect or torsion on it together with its bending nature. This is in the diagram 2, which is explained now. So if we apply the load in some appropriate point of the cross section, then the body experiences only bending nature. Okay, that point is called shear center. Again the same thing, I am repeating the concept. Okay, so next is shear center is a point through which the applied shear force does not produces any torsion or twist of the member if we apply the forces through that point. These are all various definitions for shear center. You can accordingly use any derivation that will make you feel good. Okay, feel easy. Okay, shear center is a point through which the shear force does not produce any torsion or twist of the member. So what happens in a member, if you are applying a load, see in this member there will be a shear force acting along this direction. Okay, shear force will move from this to this direction. See, if this is an angle section or I section, here the shear force will move like this, like this, like this, like this, like this, and it goes like this. Okay, so the applied shear force, this should not, so there will be a resultant for this shear force along this direction and along this direction, right? So that shear force should not produce any twist of the member if we apply the forces through that point. So somewhere around this point we have a shear center and we are applying a load along this direction, then this force should provide, or it should provide such that there is no twisting in this member. Okay, for each cross section their shear centers may vary. For angle section there will be one shear center, and for I section of different unsymmetrical I section also you may have different shear centers. Okay, that will see. The another important point is that twisting effect on any cross section occurs due to unbalanced moment created on that object due to the application of force in certain point. So the main twisting effect is due to the unbalanced moment. Okay, what is that? See, you have another angle section here, and I told that, say, the shear force is distributed like this. It is going like this and it is going like this. Okay, so this shear force will try to move this object here, and a shear force along this direction. So the resultant will be along this direction. This will have this angle section will try to rotate in this direction. Okay, so in order to see, it will go, this member will move like this. There is a chance of moving this member like this, right? So in order to avoid that twisting, at this point you are applying a load such that the total loads are balanced and there is no twisting. There will be forces along this direction and forces along this direction, but these forces are applied at this point, and this point is called as shear center for this particular section. Okay, now we will see one more thing. See, for sections having two axes of symmetry, see, this is a rectangle, this is square, this is a square, hollow circle, this is a square, and this is a circle, and you have an I section and a rectangular hollow rectangular section. For all these 5 members, you are having 2 axes of symmetry. Whether you cut like this or cut like this, the both spaces will be same, both area will be same. That is meant by axis of symmetry. Okay, so in that case, the point at which the 2 axes meet will be its centroidal axis, and that point will be the shear center. That means the centroidal axis or the centroid point as well as the shear center will coincide at a same point. Okay, for all these cases. Now, if the member is having only one axis of symmetry, see, for here you can cut like this only. Okay, you cannot cut like this. Okay, this will not make a same material here. Okay, here also like that. You can cut like this. You can also cut like this. For all these members, the shear center will not be at its centroid, but the shear center remains at the axis of symmetry. See, some distance from the center of from the centroid in the axis of its symmetry. So shear center will be there at the axis of symmetry. That is what we have explained. If cross section have only one axis of symmetry, shear center is located on axis of symmetry and it will not coincide with the centroid of the structure. Okay, clear? Okay, now we'll see how to locate a shear center in the next class.